So this is a video of the quiz 10 practice and review. So this first question says create a box and whisker that represents the given data. And so what we're going to do is we're going to enter this data into our list 1 on our calculator, and then we're going to pull the 5 points that we need. So I'm going to show you this one time on the TI-30, which is the calculator that I have in class, and one with the TI-84, which is the calculator some of y'all have, but I'm not going to show it to you the rest of the time. Okay, so here, you can click data. When you do that, it's going to give you your list 1, and so we're going to go ahead and put these data points in there. I'm going to do 80 and 95, 76, 65, 80, 88, 91, and 72. Okay, enter. Okay, there's our data there. I'm going to go ahead and do the same thing over here with this TI-84. So I'm going to click stat there, and when I do that, I'm going to go enter. That's going to give us our list here. Now, if you already had something in there, then you click up at the top and you clear it, and you click enter. Okay, now what I usually do over here is delete. There is a way to, with the TI-30, there is a way to clear it, but I just usually delete it. Okay, so once we do this again, now over here, we're going to go ahead and enter our data again. 80, 95, 65, 80, 88, 91, and 72. Okay, so once we've done that, over here, we're going to click data again. Sorry, we're going to click second data. See where it has one variable stats here? Then we're going to click enter. Now, when we get here, we have to click 3 times till it calculates. Okay, so it's saying the data is in L1, frequency is 1 time, the calculations are, there we go. So then it calculates all of our values, if you notice. Over here with the TI-84, we're going to click stat. We're going to scroll over to calc there, and we're going to choose our one variable stats there. So here again, we got to go enter, enter, enter. Then it's going to give us our information. Okay, so what we want to pull from here is, first, I always want you guys to check this n equals 8. There were 8 numbers that we entered. Over here, it says n equals 7. So how many were there? 1, 2, 3, 4, 5, 6, 7, 8. So that means I must have missed one over here. So let's go back here and look at this list and see what I missed. So I got an 80, a 95. Oh, I missed the 76, y'all. So I'm going to actually just go down at the bottom and add it. 76, enter. Okay. So hopefully now let's check. 80, 95, 76, 65, 80, 88, 91, 72, 76 was the one we added. Okay. So we're going to go back here to stat again. We're going to go over to the right and calculate. Now that's why I like actually to look at my n equals, because it tells me whether I have the number, I entered the number of values in that I actually had. Okay. So here again, we've got, so what we want to pull is our min, our Q1. If we're going to do a plot, right, we want to do Q1, minimum, Q1, median, Q3, and max. Those are the points we're always going to pull, those 5 points, okay? And they will be at the end of both of these. So there you go. I'm going to keep scroll down over here. So we've got our min, see it, min over here, our Q1, our median, our Q3, and our max, okay? And they're the same for both of them. I just looked through them just to make sure, okay? So now we're going to pull these values, all right, from our calculator. So I went ahead and wrote those things. So we got 65 here. We got Q1 was 74. Our median was at 80. Our Q3 was at 89.5. And our max was at 95, okay? So we're going to go ahead and put a dot at 65 right there, and I'm going to go ahead and label that 65 since it's not exactly where it needs to be. Then our Q1 is going to be at 74, so that's right there. And so that's what I did in red. Okay, then we're going to go to our Q3, and that's going to be 89.5. So that's going to be like a little bit below where 90 is. Okay, now I'm going to go ahead and close this box right here. Okay. So there's my box of my, not the prettiest, but it's okay. So then we'll talk about our median. There's our median, and it's at 80, so it's right there, okay? So then we're just going to do our max here, which was at 95. And again, I'm going to go ahead and label it 95. And then I'm going to draw my lines. So that's my box and whisker plot, right? So 74 is our Q1. Our median is at 80. Our Q3 is 89.5. Our max is at 95. Our min was at 65. Okay. So next it says the times of the top 10 finishers in a race are 66, 65, 66, 67, blah, 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 all those. Okay. So I'm going to go ahead and show you all this one again, but I'm going to enter it quickly because I want to show you the mean and the standard deviation on here. Okay. Okay. So I clicked on data, entered my points there. Here I clicked on stat, I clicked enter, and then I added my points there. Okay. So over here on this one, we're going to go second data and enter. And remember, we got to enter 3 times here so it calculates our values, okay? Over here, we got to click stat, go to the right to calc. We're choosing one variable stats again. Okay, that's what we're choosing on both, okay? So notice here, again, I guess I made another error. So I got 9 values entered here. Let's see how many I got entered over here, y'all. Where's n? I skipped n, didn't I? Did I? N equals 10. So yes, I forgot a value again. So let's go back over here and enter. Now you guys see why I do this, right? Okay. So I got 66, 66, 65. Skip the 65, y'all. So I'm going to go down here and I'm going to add the 65. Enter. Okay, let's see if we have the same values now. Stat again, to the right calc. Enter, because we wanted our one variable stats. Okay. So let's see if we have the same values now. 67.7, yes. Okay, remember, that is our mean, the x with the line over it, right? And this sigma symbol here, right? See that? That we don't want the s, we want the sigma symbol. So that's 1.9. That's going to be my standard deviation, okay, guys? All right, so now let's go back and look at and enter these data. So hopefully you remember our range is our max minus our min, and our max was 71, and our minimum was 65. So that value is going to be 6, right? Our mean was 67.7. Q1 was 66. We pulled all of this from our calculator, okay? Median was 67. Whoa, I don't know what happened there, y'all. Median was 67. Q3 was 70. The IQR, remember, is Q3 minus Q1, okay? So that means we're going to go 70 minus 66. So that's going to be 4. And then our standard deviation was 1.9. Now it says, what does the mean and standard deviation indicate about the data? So the mean is, it basically means that it's the average of the data. You're right. So when I talk about, it's the average point. So we basically add them all together, divide by the number of items there are, right? Okay. Now the standard deviation has to do with the spread of the data. Standard deviation basically is how spread out the data is from the center. Okay. So how spread out the data is from center. I should say is there, huh? From the center. Okay. That's what the standard deviation tells us. And normally, if we're going to talk about mean and standard deviation, we're going to compare them to something else, guys. Okay. All right. So this one says the SAT verbal scores are normally distributed with a mean of 450 and a standard deviation of 100. Okay. So the mean is the mu. Remember, mean is the mu, and we put the mu right there, right? So we're going to say 450 right there. Then we're going to add and subtract our standard deviation. So what's going right, we're going to add 100 to 450. That's going to give us 550. And then we're going to add another 100. So that's 650. And we're going to add another 100. And that's 850. Okay. And then going left from the mean, we're going to subtract. Okay. So we're going to subtract 100. So that's going to give me 350 here. Again, subtract. That's 250. Again, subtract. That's 150. Okay. So now, when we talk about this, we're going to talk about these percentages. Now, you guys have this curve on that formula sheet. So I'm just going to put in here what you guys have on there. This is 34%, 34%, 13.5, 13.5. This is 2.35. This is 2.35. And out here at the end is 0.15 and 0.15. And the only reason I'm doing this is so I have something to write on. So it says, using the empirical rule, what is the probability of scores over 550? So that means, y'all look up here. That means I'm going from here. Actually, let me do this in a different color than that green. So I'm going from here over, right? So over 550. That means all of those, right? So I'm going to add 13.5 plus 2.35 plus 0.15, and that's going to be 16%, which we also write as 0.16. Remember, you moved the decimal place 2 places to the left, okay? The next one says between. Okay, so I'm going to erase this so we don't get confused. So we're going between 450 and 750, right? So between 450 and 7... Whoa, did I skip? Oh, I did skip, didn't I? Haha, this should be 750 over here. You guys catch that? I just caught it. That should be 750. There we go. So that's 750. So we're now going to add those together, right? So we're going to add 34 plus 13.5 plus 2.35. And when we do that, we got this, okay? All right, so the next one says using the empirical, what's the percentage of scores that are at most 350, okay? So on this one, we're talking at most, all right? So I'm going to then erase again my little line there that I did. So this is at most 350, so that means I'm there, and I'm going this direction now, right? So looks to me like those are the same numbers we added a minute ago, only in a different order. 0.15 plus 2.35 plus 13.5, and that's going to be equal to what? That's going to be equal to another 16%, right? Which is equal to 0.16, okay? Then using the empirical rule, it says what is 68, what two values do the 68% fall between? Okay, so once again, if we have that 34 and that 34, isn't that 68%? So that's within one standard deviation of our mean, right? So that and that are 68%, right? So that means we're between 350 to what? 550, right, y'all? Okay. So here's our next question. This is all review. The rest of this is review, guys. So we're going to go ahead and do these. So we got our a to the fourth, and we're going to subtract the 1/2 from that because it's in the denominator. Then we have our b to the negative 1/5, and if we subtract a negative, aren't we going to add the 3/5? Okay, so 4 minus 1/2 would be a to the 7/2, and you guys should be able to do this right in your calculator. I'm going to show you that in just a second. And then b is going to be, isn't that going to be 2/5? Okay, so that would be answer B. So let me show you guys this in the calculator. So watch me again. If I do 4 minus 1 divided by 2, y'all, what do I get? 3.5. And if I want to see that as a fraction, I just click my double arrows. See it? Okay, over here, if I do 4 minus 1/2, 1 divided by 2, enter. Again, I get 3.5. And if I want to see this as a fraction, I push math and then 1, and it shows it to me as 7/2. So nobody should get this wrong because all we have to do is do this on our calculator and then see what it looks like. So with number 5, remember, we're always going to condense first before we solve, okay? Because this is a solving problem. So we're going to say log base 5 of 8 times x plus 3 because it's being added. And remember, when we condense, we multiply. And that's equal to our log base 5 of 27, right? So now, because we have the same log base 5, they cancel each other out. So that's just going to be 8x plus 24 is equal to 27. Going to subtract 24 from both sides. So that's going to be 8x is equal to 3, and then we're going to divide both sides by the 8. So x is equal to 3/8. And when we do 3/8 plus 3, obviously that's 3 3/8. That's a positive number, so it checks out, okay? So our next one says solve. Okay, on this one, I'm going to do this 2 different ways, okay? So I'm going to write it as a log first. Log base 3 of 27 is equal to x plus 4. So the first way is I notice 27 is 3 to the 3rd. So I could do this log base 3 of our 3 to the 3rd, and that equals our x plus 4. When I do it this way, remember, if I have the same bases, they cancel each other out, right? So I'm just left with 3 here is equal to x plus 4. Subtract 4 from both sides. So that's going to be negative 1 is equal to x, right? So the other way we could do this is we could do it with the change of base formula, right? So when we get to where we had this step right here, This step right here, we would keep that the same, but our next step would be what? It would be log of 27 divided by the log of 3, and that would equal 3. And so when we got to that step, it would be 3 equals x plus 4. The rest of it would be the same. So our answer here is x equal to negative 1, right? And obviously, negative 1 plus 4 is 3. 3 to the third is 27, okay? So on this next problem, number 7, it says expand. So on this one, the first thing I'm going to do is reduce, okay? Anytime you can reduce, you should. So 2 goes into 6 3 times. So what I told my students is wherever the bigger value is, that's where your answer goes when you do this, when you simplify. The next one is y to the, y'all see these y's right here? So what is 7 minus 5? That's 2, right? So it's going to be y to the second on top. And then we're just left with, I can't even see that now, x on the bottom, right? So the x is going to stay on the bottom. Okay, now we're going to break this up. So this is going to be log of y squared. Remember, anything that's on the denominator, we're subtracting. So this is going to be log of 3 minus log of x. And we are going to break those up. Don't forget that. Now, the last step is we're going to move this to the front, okay? So that means our answer is going to be 2 log of y minus log of 3 minus log of x, right? And that was D. All right, so number 8. This is one like we just did in the warm-up yesterday. So this is going to be y to the 18 divided by 6. Remember, index is the denominator, so whatever's in that check right there is the denominator. This is y of 12 divided by 3. So this is going to be equal to y to the 3 over y to the 4. Remember, we subtract what's in the bottom, right? So we're going to do 3 minus 4. So this is y to the negative 1. And that means it goes to the bottom. All right, on this next one, the first thing we're going to do is divide. Actually, you know what? We're going to, again, condense first. We're going to condense. So we're going to move this 4 to there. So this is going to be ln of 2 to the 4th, which is equal to ln of 3x minus 8. What is 2 to the 4th? ln of 16, right? That's equal to ln of 3x minus 8. Now, if we have ln's on both sides of the equal sign, we can cancel them, right? So this is going to be 16 is equal to 3x minus 8. We're going to add 8 to both sides. So it's going to give us 24 is equal to 3x. So we're going to divide both sides by 3. So x is equal to 8. And 3 times 8 is 16. 16 minus 8 is 8. Sorry. Wait. 3 times 8 is 24. And 24 minus 8 is 16. And ln of 16 is obviously equal to ln of 16. Okay? So here's the next one. Which statements describe the graph of f of x equal to e to the x minus 2? So this is going to be an exponential, right, guys? So let's look here. Let's walk through these statements. So the horizontal asymptote, you know what? Let's just do this. So y does equal negative 2, right? What's our domain here? So the graph's going left and the graph's still going right, right? So this is going to be negative infinity to infinity, right? And the graph is increasing, isn't it? So I'm going to write that. Then let's talk about our range. So our range is what? From negative 2 on to infinity, right? Y'all see this asymptote right here? There's a horizontal asymptote right there, right? So that's where the graph starts for our range, and it goes up and up and up, yes? Okay, then let's talk about our end behaviors. As x approaches the right, where's the graph headed, y'all? F of x is going to infinity, isn't it, y'all? Okay, and as x approaches negative infinity, what is f of x approaching? Isn't it approaching negative 2? All right, now let's just check these statements down here. So horizontal asymptote, yep, that's true. So that's got to be one of my answers. The range, oh, that's not what I got for the range. I should have a negative 2 there, right? So that's not true. The interval of decrease, well, no, this graph is increasing, isn't it? So it should say increase there. That's not true. The domain is negative infinity to infinity, isn't it, guys? So that's also not true. So our last one, as x approaches negative infinity, f of x is approaching negative infinity, or negative 2, isn't it? So that's our correct answer. All right, when I talked to my students about this question, when we had it on our warm-up this week, I went ahead and put a dot right there because everything to the left of that is negative and everything to the right of that is positive. This question is asking you on what intervals of x are the values of y positive, okay? So we're going to talk about that. So from -4 to what? -2, our values are negative. Y'all see that? Whereas from -2 on to infinity, what are our values of f of x? They're positive. Y'all got me? So let's just look at these answers. So from -4 to -2, those are all negative values, aren't they, guys? So that's obviously not our answer. So from -1 right there to 4, those are positive, aren't they? Let's just look at the other ones from negative. So this one was all, wasn't this one all negative, y'all? Okay, so from -3 to 3, that's both negative and positive, right? I'm going to go ahead and write this just so we can see it. And from -5 to infinity, that's also negative and positive, okay? So that's how you can differentiate these. A couple more. So what would we do first with number 12 if we're solving it? Wouldn't we divide everything by 6? Yes. Again, in the way we know that we don't take it to a power is because we got a number on the other side. That's how we do these differently, okay? So this is going to be log base 3 of 2x plus 5, and that's equal to 2. Now we're going to write it as a log. So we're going to take our base, remember we're going to switch the other two things, to the power of 2, and that's equal to 2x plus 5. So that's going to be 9 is equal to 2x plus 5. Going to subtract 5 from both sides. So that's going to give us 4 is equal to 2x. Divide 2 into both sides. So x is equal to 2. So check that 2. Make sure you always check it. 2 times 2 is 4 plus 5 is 9. So that's a positive number. So that will work. Okay? So on this one, what are we going to do first? I'm going to actually multiply both sides by what's in that denominator, 6, the square root of 6x minus 35, which means I'm also multiplying this over here by the square root of 6x minus 35, okay? So that's going to give me the square root of 6x minus 35 is equal to x minus 5. So how do I get rid of a square root? I square it on both sides, right? So that's going to get rid of the square root, right? So this gives me 6x minus 35, and when I square that, and you guys can use the box if you need to, this is x squared plus, nope, minus. It's going to be minus 10x. Swoop. I don't know what I'm doing, y'all. Minus 10x, and what -5 times -5 is 25, right? So then we're going to subtract the 6x and add the 35. So subtract 6x, add the 35. That's going to give me x squared minus 16x plus 60, and that equals 0. So what do you think I'm going to do next? Yes, I'm going to factor this. And we've done a bunch of these, guys, so you should be able to see the pattern by now. What are the factors, y'all, of positive 60 right there that add up to be negative 6? Isn't it going to be minus 6 and minus 10? So this is going to be x equals 6 when we set it equal to 0, and this is going to be x equals 10 when we set it equal to 0. So now, what must we do with both of these answers? We got to check them, guys, okay? So you got to put them back up here. So I'm going to erase all this mess up here, and we're going to check these, okay? So if I do 6 minus 5, that's 1, right? And then if I do 6, sorry, I don't know why I put... Sorry, 6 times 6, that's 36 minus 35, right? So that's 36 minus 35. Isn't that going to be the square root of 1? So what's the square root of 1? So that's going to be 1 over 1, right? So that is the answer 1 right there. All right, now let's check the other one. So now we're going to check the 10, okay? So we're going to do 10 minus 5, that's 5, right? So down here, we're going to do 6 times 10 minus 35. That's going to be 60 minus 35. Isn't that going to be the square root of 25, y'all? Which is what? 5. So that's going to be 5 over 5 again, which is 1. So this is going to be our answer. Just remember, you got to check those, guys, okay, to make sure they're going to work. All right, so here's our last problem. it says if y times the log base 6 of x over z is equal to w, where w, y, and z are both all positive, which expression is equal to x? So we want to solve for x, don't we? So I'm going to rewrite this, y times log base 6 of x over z, that equals w. So the first thing I'm going to do is divide both sides by y. Y'all see that? So I'm going to divide both those by y. So that's going to give me log base 6 of x over z equals w over y. Now, because my answers are all written as exponentials, I'm going to write this as an exponential. So my base is right there. So that's my base, 6. Remember, we're going to swap sides now. So we're going to do 6 to the w over y power, and that's going to be equal to my x over my z. Now here's my question. How do I get rid of something in the denominator? Don't I multiply both sides by z? I do. Okay, so now those z's are gone, and I'm just left with x. So my answer is x equals z times 6 to the w divided by y power. So which answer was that? That one right there.